Hey everyone, welcome to the very first Sendcloud engineering meetup. My name is Arjen, I'm VP engineering at Sendcloud. And maybe you're surprised like, hey, we got a message today that Miguel will be the host. Well, sorry if you're coming here from Miguel, he's ill, so I'm taking over for Miguel. So wish him all the best. So Sendcloud engineering meetup, what's it's all about before we go to the talks today. So what we're having here is like I'm having a great time at Sendcloud here building a large team. And with such a large team, we have quite a lot of people now with very interesting skills and lots of experience. And we'd actually like to share that with you. That's one part of the Sendcloud engineering meetup. The other part is that we'd also like to learn from you. So we also invite external speakers, people who have a great story, to do a talk here. And so that it's, we'll learn from that as well, and we get better too. So that's actually what the Sendcloud engineering meetup is about. So we'll always have two speakers from Sendcloud and an external one. And today, the external speaker, we're very happy to have him here, is Alex. Alex is online. He'll be presenting his talk as the first speaker. Alex is QA engineer, and he's a Postman supernova. And in his talk, which is called Increasing API First, Increasing Quality While Reducing Cost, he will be explaining why API design should be the first design you think of in any system you build. So API first in the very first design step. So yeah, very interested to hear about that, Alex. Then the second speaker is a Sendcloud speaker. That's Evgeny. And Evgeny is going to talk about the Order API and Order SDK and how that helps us scale out further and with a larger user base and more carriers. So that's what will be the second talk. During the talks, you can submit your questions on the chat, and then our friend Floor will collect them, pass them on, and as a host, I will ask them to Alex and Evgeny. But first talk will be starting now. So Alex, thanks for joining. And I'd say take it away.
Hi, everyone. First of all, thank you, Arjen and the Sendcloud team for letting me being here and being part of this. I'm quite excited to be here. And as Arjen said, I would like to have a chat with you about the API first approach and why I think can help you increasing the quality of your products while reducing the development costs. Okay, as you already know, I'm Alejandro Lopez, but you can call me Alex if you want. I'm from Malaga, Spain, and I'm a software engineer with a strong background in quality and testing. And here in the picture, you can see me saving someone from drowning in the cold Stockholm's water during my holidays. There were some great holidays, actually. And yes, I'm a Postman supernova too. If you're wondering what it is how Postman called the ambassador program. So I just joined there because I received a lot of support and I've learned a lot from software development and testing communities. And I wanted to give something back to them. So I just wanted to share the little things I learned day by day in my job with people. If you think you would like to apply to the program too, you can check the link at the bottom of the slides. And you will find all the information there, and you will also find how to proceed with the application. And in any case, if you need to contact me for any question or about any topic, you can ping me through my social networks, Lopez Ariza, Twitter and LinkedIn, and also through my personal website, alopezari.com. All right, let's get started. I remember when I started using computers that I mostly used back then. I mostly used desktop applications, and most of the websites I went through were static websites. And technology has evolved a lot. New architecture models have appeared, and new ways of implementing things, new components. And this is how you can be able to nowadays, for instance, to play a song on Spotify in your laptop, in your smartphone, in your smartwatch, in your car, or even in your PlayStation or in your iPad, or in multiple devices, and even through other web applications. And apart from a lot of systems and a change in the infrastructure, I think one of the keys for reaching this scenario are APIs. But before talking about APIs, let's jump a bit about software quality and processes. I'd like to talk a bit as an introduction about the software development lifecycle of a project. You can see here in the slide both a couple of software development lifecycle models. At the left, you can see the sequential one with a picture of the classic waterfall. I bet you all know about it. And at the right, you can see an example of incremental and iterative model. In this case, well, you know, probably, I'm sure you know about this because all the agile methodologies are based on this model. And in the sequential one, in the waterfall, you can see the classic approach where you define the requirements for the full product, and you design the full product, and you implement it and test it, and then you maintain it. And while in the incremental and iterative model, you can see that you pick a small piece of functionality that should be working on its own, and then you prepare the requirements for this, you design it, you implement it, test it, and then you pick another piece of functionality, and you do the same cycle, and you integrate with the previously existing one, and you keep doing this all along until you reach the full product. And of course, there isn't any model that is perfect, or there isn't such a thing as a perfect methodology, or a perfect model, or a perfect framework or library of software. Each one of them has their own benefits and drawbacks. But there is a strong point in the incremental and iterative model that I like to point, and it's I think this is a great benefit over the sequential model, and it's that you test earlier in the software development lifecycle. And not only that, you add different levels of testing, and you provide earlier feedback. And as we can see the next slide, I think this is actually quite important because failures get way more expensive as time passes. Detecting and fixing failure in the production phase of your software development lifecycle is way more expensive than in previous stages. For instance, in the requirements phase. And I can see many reasons for this. So far, for example, two of them. One is if a failure reaches production in your software, they can cause problems to customers. They can lose the confidence in our product. We can lose customers. We can lose money. And of course, we don't want that. We want our customers to be happy. Another point about this is that if we commit a mistake in an early phase of the software development lifecycle, like the requirements phase, we might spend a lot of time working over a wrong feature, something that works but it's not what we expect. And if we realize too late, we have spent a lot of time on something that we don't need, and we need to spend more extra time that wasn't planned at the beginning in order to fix that. And actually, there is a third reason that I can think about so far right now, and it's that modern software is based on in modern applications we reuse a lot of software, a lot of components. So if you add a defect on a component and you reuse them on multiple places in your product, you are multiplying the failures. So actually, there weren't two reasons for this. There were three, but if you think carefully, you will find many more. Now we can see an approach of developing a new feature that I've seen in many teams now, that consists of you start with defining the requirements and you prepare the user interface. Well, this is based on the classic web application that comprehend the backend on a software and the UI, okay, the full product with user interface. So you prepare the requirements. After that, you gather all that information into the user interface mockups, and then this acts as a new level of requirements for the front-end and back-end development teams. And both start working on that. Of course, the front-end the front-end team knows better the details of the new requirements because they know better the flows of the user interface, and they request what they need to the back-end development so that they provide them points in order to fulfill the new functionality. And once the full flow is ready, everything is unblocked, and you can start perform the end-to-end testing. Of course, you can perform testing at different stages, but in order to perform end-to-end testing and over a already developed product, you need for all the phases to be ready for that. I can see many problems here. For instance, if you think about requirements based on the user interface mockups, on the user flows, on only that, the requirements might be biased by the existing functionality on the user interface. So I think the requirements should be based on the feature itself. It doesn't matter of the implementation. They could find unexpected API limitations because, as we said, if you focus on the user interface, on the UI mockups, in order to fulfill the requirements and to show them to the team, of course, you will, at the beginning, you will find, or you will plan more or less and design the endpoints that you need to create or modify in order to fulfill those new requirements. But usually, in my experience, there is not enough time for this at the beginning. So teams end up creating the endpoints so that they fulfill the needs in the user interface, but probably some details are missing in the beginning because we don't have enough control of the changes in the backend because the requirements are based on the UI mockups. And this might lead to unexpected limitation that might cause some rework in the later stages of the software development lifecycle. So this is another problem that I can see here. Also, as we saw in this slide, in the previous slide, the frontend shouldn't be able to be ready until the backend finishes because the frontend teams need to know what the APIs are returning in order to test properly the new changes. So we can see some dependency there that could cause some block in the software development lifecycle. Another problem is that, as we saw earlier, early testing is crucial. It's important to increase the quality of our product and our applications. And in this way, end-to-end testing comes too late because it needs the backend team to finish their work and the front-end team to finish their work. And after that, everything will be ready for testing, at least at a end-to-end level. Of course, you can perform earlier testing in both systems, UI test and integration test and backend test, but API testing. But the end-to-end testing might come too late in the software development lifecycle. Also, this way of working might lead to poor communication and collaboration because requirements might be based on the user flows. So some details of the implementation, on the backend implementation, might be missing, and there it leads to both teams to perform an extra effort on communication. And probably, if you are in a hurry, this will be a disadvantage. And also, APIs might become messy and hard to maintain because, as we said, if requirements are based on user flows and UI mockups, you would create the endpoints and modify them so that it fulfills the front-end needs. So you are not taking actually care of the APIs as it deserves. And it is quite important because as we have a backend and a frontend, we need to take care of the systems that communicate both, which is the API in this case. So I think we should pay more attention to the API. And this is where API first comes. If you find anything on the internet about API first, you will see probably this sentence: treat your APIs as a first-class citizens. In software development, a first-class citizen is an entity that fulfills all the operations of the other entities that connects to. So this is more or less what we need to apply, the mindset we need to apply to our teams when working with APIs. We have a system that connects to other systems in our web application, in our product. And this is APIs. It doesn't matter if it's an event-driven API or a REST API or GraphQL API. So we need to be aware that this is a quite serious component in our system and the most used by other components as well, probably in a high-level architecture. So taking care of considering the previous example, if we apply the API first mindset to this, we would perform some modifications to the flow. And it's actually as simple as adding an API specification early. For me, this is the key of this approach, because that way you are creating a contract of your APIs. So you are designing and planning. You need to plan and design in advance how your APIs are going to behave and what they will need to request. And having this document in advance will have many benefits for other teams, as we can see here. The backend team will be able to know in advance what they need to send through our APIs. The front-end team knows in advance exactly what they are going to retrieve from the backend. And in case of the end-to-end testing, in case mostly of the automated end-to-end testing, you have means to prepare the automated checks in advance for both APIs and also front-end if you know the UI mockup and the API specification in advance. And as I said, to me, API specification is the key for API first. And not only having a proper API specification, but having it early. As I said, an API specification is just a contract that defines how your API behaves and what it will return and what it expects. You can there are several libraries and standards and descriptions for creating a proper API specification. For instance, you can see the logos here of OpenAPI, Async API Blueprint, and RAML, the RESTful API modeling language. I think, in my opinion, the two most famous of them are the two at the top, OpenAPI and Async API. OpenAPI is the former Swagger, and this is both the OpenAPI and Async API are standard actually now. So you will find it in a lot of places. And let's take a look to how an OpenAPI specification would look like. This is just a JSON or YAML file that defines different aspects of your API. So this is quite interesting, in my opinion, because this is a contract that is understood by both people and machines. So if you have this document in advance, you will know how the API will behave. It doesn't matter if it's developed yet or not. This is for people. But in case of machines, this is a document with some keywords. So you can create scripts that can parse this information in order to automate some different stuff that we will see later in this presentation. Let's start talking about the API documentation. If you are working in a public API or something that will be consumed by your customers, you should be able to keep in mind that you will have two different, probably more, but at least two different kind of readers of your documentation. The developers or the tech people and decision makers. In case of decision makers, you can't automate anything because you need to explain and write some texts and explain the flow and how your system works, what it solves, and you need to be prepared to this kind of readers, the decision makers, because you need to tell them why they should choose your product. But in case of API users, in case of the developers or tech team, they are interested on another aspect of your documentation. For instance, how an endpoint works, what it requests, what it will return. And in this case, if we have this information in advance, by the way, I won't spend too much time with the specification. You can check the details in Swagger in our website. And if you need to, of course, you need to publish this information, how the endpoints works, what they request, what they return. This is what developers are interested on. And if you have the specification, you will be able to parse this information and automate that. So you will make sure that it's correct, it's up to date as part of your specification, and you will save some time, as we saw in the graph. In a business, saving time is saving money. So automating things is a real business, actually. You can automate technical API docs with multiple tools, multiple libraries. Here I've chosen the three most famous that I've seen in the internet. Of course, Swagger is one of them. Postman is another tool that lets you create API specification automatically, well, leaving documentation, and very easily actually. And the other one is Apiary, that accepts many kind of specifications as well, like the API blueprint that we saw at the beginning. Let's go to API mocking. For me, this is the key. This is related to the key that I mentioned in the API first approach. As I said, for me, the key is having early a proper API specification document before starting the development of the product, of the features and functionality. And this is a scenario, well, two scenarios that we will see here, where we will be able to see why it is important having that document in advance. Let's check. Well, we have two different scenarios. One where we will be able to unblock the development of different teams, and other one where we will be able to add independency from third parties in our system that we can't control. Let's start with the unblock development scenario. This is a usual scenario in a development team. We need to create a new functionality, a new feature. So we need to add some changes, a new endpoint, or modify an endpoint in our APIs and in the related changes in the backend, so that it fulfills a new feature. And of course, we need to add a new functionality or new changes in the user interface. It doesn't matter if it's a web application or a mobile application or even another service that consumes this service that we are modifying. So this is what we want to reach, okay? We want our systems to be able to call the API that implements the new features so that they can test and continue with their own development. But what happens if the new changes aren't ready yet in the API, in the backend? Okay, so if we have in advance a proper API specification that we can parse, and we can use that to create an API mock of that endpoint that is not developed yet, but we know how it will work and how it will behave. So we can simulate that endpoint, which is way faster than creating it from scratch. We can simulate that endpoint so the front-end team or other APIs working on another service will be able to retrieve the same information that we would expect from the real endpoint. But there isn't any logic here, just this is a simulation. This is the key of having early proper specification. Yeah, you can advance some work and avoid blocking. And this is why I think it can help the speed of your development process. There is another scenario. Well, if once the real endpoint is finished, you can move again your applications to the real endpoint instead of the mocked one, and this is all. And the other scenario that we have here is the getting more independency from third parties. Let's suppose, as a tester, for instance, or as an API consumer, that you are consuming your API. Okay, you are testing it, and your API is consuming another API from a third party that you can control because it's from another organization or is a public API or whatever. What happens if you need to test something right now, but your third party isn't working properly or isn't clearly developed or isn't finished yet, and they are constantly deploying new versions with changes, or they are down because for whatever reason? You can't use that, but you can do the same. You have existing responses. You can check the documentation. You can mock that third party in order to and move your actual endpoint to that mocked endpoint, so that you simulate how the third party works and you can proceed with testing. And of course, we are talking about testing. Actually, this is at the beginning. We could think that this is an API talk or a testing talk and quality, but this is a spoiler. It's not actually a testing or quality talk or API talk. We will see it later. But regarding testing, shifting testing left into the software development lifecycle has many benefits. As we saw, we save a lot of time and a lot of money if we test early in the software development lifecycle, like testing properly the requirements, testing the design, testing the implementation, and of course, doing it at different levels and planning it properly. If we have, before implementing the new changes, if we have a proper UI mock of the new feature that the front-end development team would create, and we have a proper specification of what the APIs would return, we will be able to prepare testing properly in advance. But we will be able also to verify that those specifications, both the mockup and the API specification, they are correct compared to what we expect from the actual requirements. That's what we need to develop. So I think API first helps us shifting testing to the left, and also helps us adding more levels of testing, like contract testing, because we have in advance a proper API specification, and we can prepare, apart from end-to-end tests, UI tests, we have and backend tests for sure. We can prepare contract testing to make sure that each system that consumes the API and the API for sure is returning what we expect. So we can test the integration between the systems in our product. Here you can find three libraries and tools for contract testing. Of course, there are many more of them. I chose those because I think Pact is probably one of the most interesting ones. If you are writing directly in your code and you have your own framework, it helps you create a consumer-driven contract tests. And it's quite interesting. It works really cool. I recommend you take a look to that if you're interested in contract testing. Of course, you can perform contract testing with Postman too, because these guys of Postman are ready for everything regarding APIs, and they are constantly adding new features. And there is another one, Thread, that I find quite interesting because it performs contract testing against your API documentation, so that you make sure that your API documentation is never outdated. I recommend you take a look to that. It's quite interesting. So in order to summary what we are seeing, and in order to finish this talk, I wanted to enumerate some of the benefits of API first approach. As we've seen, it can help you remove the dependencies between your development teams, because you can mock things and you have contract in advance about how the communication between those teams and those products will happen. So you can prepare everything in advance. Considering that, of course, teams can produce faster because they have more information in advance. This is validated, and in most of cases, and you can remove blockers between teams. And in consequence, this reduces the development costs. And of course, it increases the quality, because you perform earlier validation of the different stages in the software development life cycle, and you can add different levels of tests too. And it provides a better developer experience, of course, because if things go smoothly and things are agreed in advance, everyone's happy, right? I bet that you know what I'm talking about. And considering that we are paying attention to our APIs and we are taking care of them and we are designing them properly and verifying those designs in advance, I say that it eases the API maintenance too. And of course, there isn't any tool that is perfect for any case or any methodology, but I recommend you that you take a look to the different libraries and tools for that. But I think that Swagger and Postman are great tools so that you find the different aspects of API first, because they guide you through the process. So I recommend you that to take a look to Swagger products and Postman products. Check all the behaviors and the features that they provide you, and then you will gain a more understanding about how to proceed with API first properly. In order to finish, I'd like to rescue this quote from Anita Roddick. She was an activist and the founder of The Body Shop. She said once that the communication is the key for any global business, and considering that API are the systems that connect modern software, I like to adapt it to APIs are the key for any modern application. So this is why API first is quite important, because APIs are the nexus of modern software projects. So it's our time now to take care of them. And increasing the speed and the quality of them will reduce problems in our products. All right. Any question?
Thanks for the nice talk. So I've got some questions here, but before I go over there, what I found interesting is with the benefits that you listed, is that the top one was my personal favorite, which is removing dependencies. It's something we discuss a lot here. Like last year we had 3 teams, now we have 9 teams, and you would expect like 3 times more output. But if you have dependencies, not, right? So if we really want to scale well, this is for us important. So cool that you mentioned that, also relevant.
Thank you.
I've got a few questions and from the audience, so let me just look them up. Hold on. All right, so quite early in the talk. So what about API maintenance? Who's responsible for that?
I think everybody in the team should be responsible of API, because we tend to think that APIs is a backend thing, but actually, it's usually implemented by backend engineers. But I think it's in the middle of your product. We tend to say, I'd like to say that user flows, the core of user flows is the user interface, because this is what they get in at a first sight. The core of the business rules, the core of your business is in the backend, but I think the core of the communications is in the API, and this is something that we all should be care of it. It doesn't matter if you are a backend developer or a frontend developer or a QA or whatever. So, and this is why I think API first approach is interesting, because in my opinion, the full team should approve the API definition before working on them, because actually we all will make use of it.
All right, thanks. And can you name an example of a great API design or API design, sorry for my Dutch, or documentation, like an open source solution or public?
Okay, I've seen 2 approaches for this. I find Postman very easy to use in order to create documentation, mostly for testers. As I'm a tester, I have to work a lot with Postman, so I find it quite comfortable to work with. Also, Swagger, of course, the Swagger specification. But regarding frameworks, there is a combination that I've seen. It's not actually a library or a tool. It's a combination of tools that I think it works quite fine, and it's producing an OpenAPI specification with whatever library that you use, probably Swagger or any other. Then creating the user interface with Redoc. This is a React framework for displaying and rendering API documentation, and testing it with Thread, the library that I chose in the contract testing slide.
Okay, thanks. What about load testing APIs? Can you tell something about that?
This is a topic that I love, actually. I love anything related to performance and load. In this case, there are plenty of them. It depends on the ecosystem and that you work on. One that I really love in Python is Locust, because it's really easy for you using Locust to reach a really high throughput, because it's really easy using them in a distributed mode. You don't have to play with Kubernetes instances or AWS instances. It's really easy working with distributed mode with Locust. I also like Key6, the Key6 framework in JavaScript. I haven't played too much with it yet, just a couple of proof of concepts. And of course, in Java, I think JMeter is the leader. There are a lot of tools for this. In my opinion, I really enjoyed working with Locust.
All right. One final question before we move on to the next talk. So you're a Postman champion. or Supernova, as they call it. So what makes Postman the superior API platform for you?
Okay, to me, of course, I haven't used only Postman. I've used Insomnia and Soap UI and other tools. They are all great. But in my opinion, Postman is a tool that gathers a lot of things that you can do in APIs, so that you have everything gathered in a single tool, and you can use it really easy. It's really easy and really intuitive. And even though their documentation is quite powerful, and they have plenty of examples, also something that I find quite interesting, because I love Insomnia too, but this is something that I've only found in Postman. They have a really powerful read or API networks. You can find a lot of existing collections for Postman, and you can find a lot of already created stuff, and this is something that you can reuse, of course. So this is what I would say. They have not a tool, but a powerful ecosystem, and they gather probably everything that you will need to perform two APIs in a single tool. So it's really easy to get started with it.
All right. Right. Well, thanks, Alex. Thanks for your talk. Thanks
Thank you
for
very
the
much.
clear answers. We're moving on to the next speaker, and that's my colleague Evgeny. And Evgeny almost beat me up backstage just a moment ago, because during the introduction, I said that Evgeny was going to talk about the Order SDK, which is also an SDK we have, but he's actually going to talk about the Carrier SDK. So Evgeny, take it away.
That is very true. Hello, allow me a couple of seconds. All right, so indeed, I'll be talking today about the Carrier SDK, or Sendcloud's story of switching to services in one particular scope. First of all, it's great to see all you here. Hello and welcome. These days, the distributed service approach architecture has long moved from being a bleeding edge startup hype thing to being a widely used way to build systems that can keep up being maintainable and, most importantly, comprehensible at a large scale. There are organizations that start with a service approach architecture from the get-go. However, the majority of companies, Sendcloud included, usually opt to face the trial of transitioning to services as a more or less established organizations, with all the technical and administrative challenges that come with it. I'm excited to share the story on how we're doing this monolith to service transition at Sendcloud in scope of integration of logistical providers, which we call carriers. In 2 years, we have built around 40 carrier integrations with the help of Carrier SDK, our technical solution to this service move problem. That's 2 times more than all the carrier integrations that we've managed to build before this move started. We expect this to be the future of carrier integration that will allow us to scale above and beyond, with us pushing the amount of integrations in the hundreds by 2025. Allow me to introduce myself better. My name is Evgeny Sharypin, and I've joined the company 3 years ago as a senior developer in the merchant team. Back then, this team was responsible, among other things, for the integration and support of carrier connection. Eventually, after a series of growth periods and splits, the team evolved to become Carrierland, a subdomain of 4 teams solely responsible for this handling of carriers. I am the current engineering manager of this domain. I've been planning, overseeing, and even occasionally getting my hands dirty with actual engineering on this project from its very early beginning in 2020. It continues to be one of my topmost priorities at Sendcloud to this day. Let's briefly look at what I'll be presenting today. I would like to take you through the beautiful story of this project today, yesterday, today, and even beyond. We will start with a short trip down the memory lane and talk a little bit about how Sendcloud looked like in early 2020, both technically and from the org perspective, and what was the reason for us to take on this big service transition. Then I will cover the basic idea on what is a carrier for us at Sendcloud, technically speaking. We'll move to the explanation on how we managed to plan and start this project with momentum and without falling into analysis paralysis. I will also cover the architectural prerequisites that allowed us to avoid both considerable refactoring as well as eventually building a distributed monolith, which is considered to be a common pitfall in these kinds of projects. I'll talk about how we arrived to the idea of turning our project into an actual SDK and its most important part, the Carrier Blueprint, a reusable Python package that serves as a base for all our Carrier services and gives us and our integrators an ability to develop new integrations really fast. It keeps the services code base lean and easy to maintain, as well as radically simplifying operational changes that we need to apply to the whole service fleet occasionally. I'll talk shortly about what we need to support a project like that in terms of infrastructure, documentation, observability, and testing. Although we have successfully developed a bunch of new carriers, we still need to move legacy ones. We call those native carriers. In 2021, we have already moved 4 of those to become middlewares with very minimal user impact. I would like to share the way how we managed to achieve that. As we are leveraging outsourcing heavily in this project, I'd like to give some quick tips on how to keep your partnership effective and have a close but not a tight connection with your partners. Finally, I'd like to give a quick word on the future of this project and how the completion of it will open up new horizons for Sendcloud. All right, so a brief refresher on what Sendcloud is. We are a company that essentially integrates a bunch of e-commerce systems on one edge and a bunch of carriers on another edge, radically simplifying the shipping part of the e-commerce business. We also provide a lot of other amazing functionality, like unified tracking experience, efficient orders processing, and so much more. However, in this talk, I will be focusing on the carrier story. All right, let's get going. So back in early 2020, Sendcloud stack was mostly monolithic. 80% of all the logic was contained within one big Django project. The carrier connections themselves were represented in a monolith as code modules, all complying to the same interface definition. These modules would do the translation of our internal interface calls into upstream calls of a concrete carrier's API. At that time, all carrier development was done internally in Sendcloud by a relatively small team. When we wanted to build a new carrier, most of this work was actually to build such a module as a sub-package in our main project. Quite a straightforward process. However, unfortunately, the story of a carrier integration doesn't end when the module is complete. As the market evolves, carriers require tweaking, bug fixing, addition and removal of shipping methods, and so on and so forth. We have quickly realized that we wouldn't be really able to keep up with the demand of new carrier integrations and all the operational work that would be required to keep them shiny. At the same time, this operational creep started to really hamper our ability to focus on the core product development. This is why we have understood that we need to open up the carrier integration process to a wider public. First, to trusted outsourced partners, and then, eventually, to any other carrier company willing to integrate with us. That's how the idea of moving these carrier modules to independent services was born. All right, let's take a look at what makes a carrier integration for us, technically speaking. Essentially, we see them all as providing similar services, and we identify 5 major ones. Those being shipping label creation, or as we call it here, announcement, shipping label cancellation, when you don't want to send things anymore, parcel tracking, scheduling and cancellation of pickups, and scraping of so-called PUDO points. PUDO stands for pickup and drop-off. Right. I would like to talk now about 2 crucial traits of our existing architecture back at that time that helped us to move on with this project successfully. As I mentioned before, a carrier is represented in our code as a module that provides handles to access all of those 5 major services upstream using the same consistent interface with a separate handle for each of those major services. At the same time, these modules were self-sufficient, meaning that They did not have the need to do any round trips to downstream code. Everything needed to communicate with the carrier was passed to the module through a common interface. This vertical siloing was one of the crucial prerequisites for the project to succeed, as it allowed us to easily design an HTTP API that would replace the existing Python API without really redefining or refactoring this interface much. The second aspect of the existing way to integrate carriers that played in our favor was the fact that we were able to keep all the state, so data on the actual parcels, inside the monolith, making our services almost completely stateless. Why stateless services are cool? Well, that's because if there is no state, you can compete for shared resources, and that makes them easy to scale both horizontally and vertically. With this in mind, we have arrived to the following conclusions. First, that our carrier modules can be easily converted into stateless services with an HTTP interface mimicking our existing in-code interface. These services, which we call middlewares here at Sendcloud, would essentially act as a translation proxy between our common API, or the common interface, which we call the carrier API, and the actual API of an upstream carrier. In other words, you can say that it's a very clear application of the adapter design pattern. And the second conclusion that we arrived to was that we would need to build a monolith side module that would link these new middlewares to the rest of our platform code. We call that one the generic SDK carrier module. Then we started planning. In the beginning, this project seemed like a real beast. However, it became way easier when we started to decompose it. First, we decided to take on this project with an API-centric approach. We've sat down and designed the new carrier API as an open API spec, defining methods for each major service and putting it in a special repository. And we have all agreed that any new developments will always start with a change to an API spec. Then we sat down and arranged all the tasks and carrier functionalities on a whiteboard, breaking them down into 3 stages. For example, our first milestone was to be able to do announcements and cancellation. Then we moved on to tracking, and so on. Doing it in this fashion made the project way more comprehensible and way less scary, and that allowed us to keep our momentum going. We have also had a nice playing ground to get going. We have decided to re-implement an existing carrier, in this case, Carrier Express, in a new format, making it a middleware, which allowed us to have a very concrete working reference to get knowledge from, to learn from, and to compare how our native carriers behave with the new middleware ones. By doing that, we have semi-consciously followed the advice from the mythical man-month book. Please let us know in the comments how many of you have read this one. They say that this book is the Bible of software development. Many of people know of its existence, fewer people actually read it, and even less people understand it. Well, I get to be honest with you because, no bullshit, I've only read summaries from it. However, one of the key ideas from that book is the concept of a disposable prototype. The authors recommend never trying to do everything right on the first try, as it is a surefire way to go into the depths of scope creep despair. Instead, what they recommend is to build a minimally compliant prototype, learn from it, and then rebuild the whole thing from scratch with a clearer understanding of what is in and what is out of scope and what could be common pitfalls. The original prototype can and should be discarded then. And that's exactly what we did with our first middleware. But in any way, doing that allowed us to complete our first prototype in only 3 months from the moment we actually started doing this. Well, once our prototype was done, we were actually started employing our first integrator partners, STX Next. Dzień dobry to everyone who is joining us from Poland. We employed them to build the first production middlewares. Back in the day, these were quite simple, written on Flask, and each of them contained both the platform to middleware communication code as well as the middleware to carrier communication code. As soon as we faced the need to roll out a patch to our, well, then small fleet, we have realized how cumbersome and how intense that will become, the project like that will become when we will want to scale our fleet. That's how we have arrived to an idea of Carrier Middleware Blueprint, a redistributable package that would contain the base app skeleton, as well as all the platform to middleware communication code. Having this blueprint, a potential change to a platform to middleware communication results in a small patch to the blueprint and then a simple dependency update in all of the concrete middlewares, instead of hectically trying to go through all of them and patch all of them in a consistent way. Additionally, having this blueprint in place allows us to keep the code of concrete middlewares very lean and easy to grasp, as those would predominantly contain the business logic, the logic of translating our API to the API of the carrier. The blueprint provides the base application class, an easy way, the base application skeleton, an easy way to implement and extend concrete carrier functionalities, for example, announcement, as well as some other quality of life things like a unified observability instrumentation. It is now a fully asynchronous web application powered by Fast API. In other words, having it allows us to remove the necessity from our partners to think about the platform to middleware communication, really enabling them on the business logic of translating our standard to the standard of carriers. I hope you can see it, but that's an actual snippet from our concrete middlewares. You can see that by inheriting from shipment service, you would already get a lot of functionality for free, including a consistent structure of building your middleware. The incoming data parameter is typed and structured in the same way for all middlewares. And the parse upstream response function uses the functionality from the blueprint to translate the response into the actual format that our platform expects. Good. I have talked plenty about architectural concepts and our way to go there, but let's make a short detour and talk a little bit about some tips on infrastructure, documentation, observability, and testing, which are also quite important aspects of this project. Infrastructurally speaking, we deploy our middleware fleet on a specially provided Kubernetes cluster with Helm orchestration. But I must say that the actual choice of technology doesn't really matter much, as long as you strive to make this a self-service deployment, meaning that your integrators can easily use your infrastructure as a service, like AWS. It's always also a good idea to follow some basic and well-known methodologies, such as 12-factor app. The references will be provided, of course. In terms of documentation, the key is to focus on developing a common format of documenting a service. Having a standard documentation template will allow you to smoothen up, for example, the process of handling over operational responsibility between different parties. However, please remember to approach this with an agile mindset, as it is really well known that the hard part of working with documentation is not actually writing it, but keeping it updated. And overly verbose documentation will really tend to become forgotten. Observability is super important in operating a fleet of services. Distributed architectures are harder to debug than monolithic. That's the praise that we pay for it. So we would really like to invest heavily into having a centralized and accessible observability stack. Remember the 4 important parts of a good observability setup: logging, metrics, alerts, and tracing. We're using the Prometheus, Loki, and Grafana stack in this project and actually all across Sendcloud, which is I can recommend to pretty much everyone. It's good, open source. Testing is also quite important, and I find a nice synergy with the previous talk here. especially as we now consider to move more and more into opening up our integrations to third parties, not partners that we work together closely. Of course, you should expect your services to be covered with unit testing, but that is not enough when you need to ensure that your services will be actually integratable. For that, you would like to develop contract testing and automated acceptance tests. Both of those should be distributed together with your SDK to ensure that integrators can test their solution without having a tight communication loop with the platform operators. Good. Now let's turn back. Let's bring it a little bit back into what we're doing with it now. So as I've spoken before, in 2021, we have started the process of native carrier extraction. This means that we aim to replace our existing legacy carrier modules within the monolith with carrier middlewares. This process is handled by our other trusted partner, Levy9. Hello for everyone for joining us from there. This process of rebuilding an existing carrier as a middleware itself is not really different from building a new one. However, there is a different challenge. We really would like to be able to switch users between those two implementations quickly and transparently. And we wouldn't really be able to do that by deploying this, as our deploy cycle is, first of all, our deploy cycle is around an hour. It would create a big bang change. And we really wanted to do this incrementally. So we have developed this so-called gradual rollout mechanism, essentially a collection of user-tied feature flags that we were able to control nicely and easily through our own platform's administration interface. This allows us to switch users between the native and the middleware version with a cycle time of 5 minutes. Such a short cycle time allows us to avoid being too cautious and improves the general feeling of safety. And additionally, since we can define a rollout percentage, it also allows us to be way more agile and flexible in doing so. All right, now I'd like to talk a bit about how to set up a productive, close, but not too tight connection with your integrators. We work together with two esteemed software development houses, STX Next and Levy9. Our partnership so far has been great, and that's because we try to push as much agency and responsibility to our partners as possible, but support them with tools and processes to develop on our SDK with confidence. Doing that forces us to think on how to develop our SDK in such a way that it's easy for an integrator to avoid being too reliant on ourselves. A good example of that would be using automated acceptance testing over doing reviews over integrators' code. Another example that we have already covered is providing partners with a solid maintained foundation, our blueprint, so they can build upon it without being bothered with maintaining the interface compatibility too much. Doing this successfully might also require some changes to how communication works in your own organization. Remember the Conway's law. Any organization that designs a system, defined broadly, will produce a design whose structure is a copy of the organization's communication structure. And Sendcloud, it was more or less an easy task for us because that's how we operate normally. We like to push responsibility, but enable people at the same time. Good. Before I pass on to the outtakes, I'd like to wrap up by talking about the future of this project in a short bit. By mid-2022, we aim to complete the extraction process. By the end of it, we would like to generalize our connection module to the point that adding a new carrier will be only a configuration change instead of a code change as it is now. By 2025, our carrier portfolio will be counted in hundreds. The future is bright. There are many other exciting possibilities for us. We could do automated service discovery. We could build an app store for our carrier integrations. Or maybe our carrier API will become an industry-wide standard to communicate for carrier communications. Good. Let's quickly collect the most important outtakes. Before attempting into a service-based architecture, ensure that your existing code is properly vertically siloed. This will make the transition from the code API to the inter-service API easy. Try to avoid distributing state, as it is a surefire way to get a distributed monolith, and that you will probably like to avoid. Define milestones, but don't go too deep to avoid analysis paralysis. Make a disposable prototype first and actually dispose of it afterwards. If you're building a service ecosystem for integrators, try really hard to give them a base layer that would allow them to focus on the business logic and not on the specifics of communication between your services. Provide infrastructure as a service to help integrators to avoid issues with deployments and preserve their focus. Use known paradigm as for example, the 12-factor app. Pay attention to allow easy handovers. To pay attention to documentation to allow easy handovers, but don't create Byzantine bureaucracy. Focus on observability to avoid debugging hell. Always try to attempt to the shortest cycle time possible, because that will make you feel safer. Push agency and responsibility to your integrators, but support them with process and tooling. And finally, remember the Conway's law and assess your organization's communication style. And that will be it. I will be very happy to get in touch with you, and feel free to reach out to me by mail or by clicking on just connecting with me on LinkedIn.
All right. Thanks, Evgeny. Very nice talk. So Heroku has the 12-factor app. We have the 12 outtakes, I see. Cool. 12 is a magic number. So got some questions for you too.
Nice.
Hold on. Just checking them now. Here we go. Yeah, so you're talking about moving code away from the monolith to the middleware.
Indeed.
How do you make sure that the engineers don't revert back to adding it to the monolith, so that the thing doesn't keep on growing?
Well, in our case, it was quite easy, because all of the Carrier development was just happening within one team.
Mm-hmm.
And in our situation, it was mostly solved by an administrative wheel. So at some point, you just say, okay, we have this new system. It's been working well. We have already built 3 or 4 prototypes. And at that point, I've let it known to the project owners and our other engineers that, yes, this is now the future. And this is now the way how we're going to be building Carriers from now on. And I don't really remember much of the friction back then.
No. I think it's probably also much more fun for people
Yeah,
to do
of course.
this. So why would you go back?
Of course,
Yeah,
people
yeah.
like also get to play with new exciting technologies and building new services, and it's always easier to work on a smaller code base rather than trying to wrap your head around this alien ship that big projects can be.
Yeah, exactly. All right, another question.
Yes.
So now we have, you talked about moving from monolith to middleware. We work with SGX Next, Levi9, who help us implement the middleware, and they can work in parallel.
Indeed.
Like, how parallel can you go? Alex talked about removing dependencies, and so here is also how parallel can you go? What is the limit in number of engineers you could do theoretically?
Well, you see, our current limiting factor is mostly the need for us to build those modules still build those modules in our system. In 2022, we would like to evolve our platform code to such a point that this will be only a configuration change. And now we have around 40 developers working on our Carrier SDK, all of our Carrier SDK initiatives, with a smaller team of 5 people supporting the actual integration into the platform. But I imagine that this could be increased at least 4-fold when we will be able to do that only with configuration.
Okay, great. Awesome, that would be a nice accomplishment. Checking the next one. Yeah, you said something about API being open source or shared with partners. Is there some kind of timeline in mind that we can do that?
Perhaps. Well, we wanted to do that this year. We weren't really ready. Maybe we will be able to do that by the end of next year.
Okay.
But at the same time, I don't think it is wise for us to open it up before we are really mature code-wise. Again, before we can make it only configuration change instead of the code change. So that would be a hard prerequisite.
All right. Okay. Then another one, and I think it's the final one from Alex. So Alex said, I'm just reading it now.
No,
I'd love to know how you try to follow the 12-factor app. Every team has a different context and its own way of doing things. So I'd like to know how you proceed with this.
well, that's a question that we can spend hours talking about.
The new meetup, next meetup.
Next meetup. Yeah. We'll talk about that next meetup. But to be nice and answer, of course, 12 factors app as any methodology, it's a very good methodology because it's at the same time quite loosely formulated, but gives you really clear guidelines. And I personally don't see much of a problem that some teams interpret it in a different way, because still, you have to always pick the correct tool for the job.
Yeah.
In our case, our DevOps team makes sure that we follow the methodology correctly. When we were just starting out, we had a series of conversations with them, and they helped us to define what would be the minimum requirements. And since a lot of our code is actually repackageable and redistributable and is made out of templates, it's an automated process, and developers just don't think about it, right? So they just click create new project, they get a new project, everything is set up, and you only need to be bothered about writing the actual code.
Yeah. Okay. There's no more questions, so I guess it was very clear. Thanks a lot. Just hang on. We're then about to wrap up.
All right.
Two great talks. Thanks a lot. The talks will be available just on YouTube, I guess, very close to right away, right? So we'll also write transcripts of this, and we'll post them on our blog. So our blog, you can find it on dev.to/Sendcloud. There's already some other content on there. This will be posted there as well with the materials, so you can read all the stuff later, or you can view it later when you want. Having said that, let's move on to the next meetup. The next meetup is on the 13th of January. You can see that on meetup.com. We'll open it up pretty soon, so then you can let us know if you want to attend it as well. And our colleague Rian, our front-end superhero, will be doing an awesome chat there as well, together with an external speaker who brings in another story. So hope to see you then, and thanks for joining us now. Bye-bye.